My name is Bogumił Kamiński, and today I will present you one of the chapters abbreviated of my Julia for Data Analysis book. Before I begin, let me just comment that the topic I will discuss today is covered in chapter 12 of my book. So you can access the source code in my GitHub repository Bekami's Julia for Data Analysis. So if you would like later to follow what I present, roughly you will have the same source code that I run right now in this repository. Let me click to show it. So here you have the whole source code. Today I will use a bit abbreviated source code for this. What this chapter is about. This chapter is about presenting you how you can analyze GitHub social network data using data frames.jl and graphs.jl. So what is this GitHub social network graph? This graph is a data set that stores information about GitHub developers. And there are various attributes of those developers collected, but the crucial attribute that we will want to investigate today is connections between those developers. So as you can see here in the dataset statistics, there are 37,700 nodes, so developers in this dataset, and they are connected by edges. We have almost 300,000 edges in this dataset, and let me comment when it is considered that two developers are connected. They are connected by an edge if they meet the following condition. So first, a developer must have started at least 10 repositories to be included in this dataset. And the second thing, that there is an edge between two developers if they have mutual follower relationship. So we have developers, and two developers are connected if they mutually follow each other. So this means that this relationship is symmetric. So if developer A is connected to developer B, also developer B is connected to developer A. And what is interesting in this dataset is that every developer is labeled or classified into two types. Either this is a web developer or machine learning developer. So what we will try to do today is to check whether we can predict the type of developer only based on types of friends of this developer in GitHub network. Because of course we could use some other means to identify if a developer is machine learning developer or is a web developer, for example, by looking at commits and contributions of this developer, but this is quite complex. It's much easier if it works to check who are friends of this developer, and the working hypothesis would be that web developers are connected to web developers and machine learning developers are connected to machine learning developers. But to check whether this is true is exactly our task for today. So the structure of the presentation will be that first I will show you how to get this data and load it into a data frame. Next I will show you how to create a graph from this data, and finally we will do some analysis of the created graph. First we will do a visualization of those developer relationships, and second we will build a simple logistic regression to predict which type of developer is based on types of friends of this developer. Let us start. So I have already started my Julia session here. So I am in Julia prompt, and today we will work with Julia repo. We could also use other means of analysis, like using Jupyter Notebook or using, for example, Visual Studio Code. But I decided to just use plain REPL because then I am able to show most of the code and results on the screen. So first thing we will do is to download the data. So I import the downloads module. This is a standard module, you don't have to install it, and the file I will want to work with will be called gitwebml-zip. This file is available at the website that I have just shown you. So this is a snap repository at Stanford. So let's first try fetching this data. So now I'm trying to fetch this data, and in my case I already prefetched this data not to delay today's presentation. So I get information that this file is already present on my machine, but if it were not present, which we've checked by bank is negation, if git-zip is not a file, then we download it from this location to git-zip file, where git-zip is exactly the name we have given earlier. So maybe let's just check if indeed git-zip is a file present in my computer. So is file git-zip returns true. So we can start working with it. And the first step in our analysis is the following, and this is a typical situation in practice. We have a zipped file and we want to work with it. So the simplest approach would be to manually extract the data, but it is useful to know how you can do this with Julia. So there is a zip file package. This package is something you need to install. I have already installed it, and I import this zip file package and then open this zip file for reading. So I'm using a reader function from zip file module and bind the returned value to Git archive variable. So we can see that there are several files in this archive. So there is a file that contains edges, and this will be the file that is interesting for us because we want to analyze connections between GitHub developers. There is a JSON file with GitHub developers features, and this is something I will skip today in our session, but I encourage you to later try analyzing also this data. And there is git target CSV, and this is the file that is also interesting for us because it stores the information whether a given developer is web or machine learning developer. So to summary, we want to extract two files from this repository. First file is this edges file, and the second is a file with target. So because I want to extract two files from it, so I want to do some repeated operation on the data on this repository. Therefore, I create a function for extracting files from a zip compressed file, so that I do not repeat the same operations twice. So here is the function that reads in a CSV file to a data frame. It takes two arguments. The first argument is the archive, so the zip file reader, and the second is file name, so name of the file in the repository that you want to extract. So what does this function do? So first of all, in archive, there is a field files that lists me the files stored in this archive. Those are exactly those files listed here. So what I find all files whose name is exactly the same as the file name that I have passed. And I expect that I get exactly one match. And in Julia, you have a very convenient function only, which takes a collection. If this collection has exactly one element, then this element is returned. If it has 0 or more than one element, then it errors. Why it is useful in this case? Because we are sure that IDX variable will be assigned only if we have exactly one match in our archive. Otherwise, we will get an error. And the second thing I do, if I have the index of this file in our archive, then I read the data from the file with this index, and then use CSV read function to read the data fetched from the archive into a data frame. Here I specify that the CSV read function should return me a data frame. So maybe before I move forward, let me just show you how this only function works for someone, if some of you have not seen it. So for example, if I write only 1, then I get 1. But if I had an empty collection, I get error. And if I have a collection that has more than one element, I also get an error. So that's why I use here this only function to make sure that I have passed a file name that is exactly matching one element in my zip repository. So first, what I need to do is to load the required packages for reading CSV files and loading data frames. So this is a CSV and data frames packages. And again, if you don't have them, you need to install them. And then I first load the edges data frame. So from Git archive, I extract the Git edges CSV, and we can see that this file has, as expected, almost 300,000 rows and 2 columns, ID1 and ID2, which give me a pair of developers that are friends. In a similar way, I ingest the information about developer types. So for each developer, we have developer ID, developer name, and machine learning target. If it's 0, it means developer is a web developer. If ML target is 1, it means that developer is a machine learning developer. Maybe before we move forward, let us see what would happen if I passed a wrong file name. So I, for example, add several banks here. And if I now try to read in the data, I exactly get the error we have expected. So the only tells me that this file was not found, and I get an error from our ingest2df function. So if we were writing a production solution, probably we could catch this error and decide what to do then. Okay, so now let us get a quick descriptive statistics of our data frames. But before we do this, there is one important thing to remember. If you open some stream, in our case we have opened a zip repository, it's a good practice to always close it after we don't need it. So in our case, we just close our Git archive so that we release the resources associated with it. Okay, so we have done it. So now let's get a quick descriptive statistics of our data frames. So first, we describe the edges df, and we can see that this is not maybe super interesting. We see that the minimum edge number, vertex number is 0, maximum vertex number is 37,699. So what information does it give to us? It gives us information that this data frame uses zero-based indexing. So probably this file was prepared with someone using, I don't know, Python or C in mind that use zero-based indexing. We need to remember that the developers are indexed from 0 to 37,699. Let's check the same with the classes data frame. So, okay, we look at the classes data frame, and here we also see that classes has an ID, developer ID has exactly the same range, starting from 0 and ending at the same number, 37,699. So the data is consistent. We have developer names, but it is not something that will be interesting for us. Let me maybe briefly comment this string 31. This string 31 type means that when we were reading a CSV file, CSV reader detected that all the strings in this file are relatively short, and because they are relatively short, instead of using standard string type, it uses a fixed maximum width string of type string 31, which means that this string can store up to strings with up to 31 bytes width, and the benefit of it is that those strings are not allocated. They are more efficiently stored in the name column. Thanks to this, especially if you had larger data, because this data is not that large, but if we had larger data, we could work much faster with it. But and this happens automatically. So CSV reader automatically detects whether it can use those narrow strings or it has to fall back to a wide string in case we have wide strings. And finally, what we see here that around 1/4 of all GitHub developers contained in this data set are machine learning developers, and 3/4 of the developers are web developers. Okay, so now maybe let us check how we can work with this data frame. So, for example, you might wonder if you are included in the classes DF data frame. So first, let me check myself. So I find all occurrences of becomings in this data frame. Unfortunately, none are found. So I was not included in this data frame. So I thought maybe let's check someone more famous, like Stefan Karpiński. And if we look for Stefan Karpiński, actually we find, yes, there is one element in this vector, in this data frame in position 1359. That is Stefan Karpiński. Let us subset the data frame to get this row with Stefan Karpiński. Here I use a different subsetting condition, so I could have just passed 1359, but I decided to say, okay, let's find the row or rows, but we know it's one row in this data frame where name matches exactly Stefan Karpiński. And this column means that we will display all rows in this data frame. So I run it, and what we learn is that Stefan Karpiński we know that he has row number 1359, and the ID is one less, so it's 8, not 9. And Stefan Karpiński is classified in this data set as machine learning developer. Okay, so now we know how to do simplest way to do lookup in a data frame. But before moving forward, let me recall you that what we want to do analysis if I can predict whether, for example, Stefan Karpiński is indeed machine learning developer, but only at looking at the neighbors of Stefan Karpiński. But before doing this, we need to do one operation. This operation is associated with the fact that we have already commented several times that this dataset uses zero-based indexing of developer IDs. So let's look at edgesdf. We see that this edgesdf starts with 0, and the same for classesdf. We see that it also starts with 0. So let's fix it. So first let's fix edgesdf. So we want edgesdf to start with 1. So we want to increment every element of edgesdf by 1. Here we notice that this data frame has only 2 columns, and they both need to be incremented by 1, which means that what I need to do is simply increment edgesdf in place by 1 using broadcasting. So this dot means that we use broadcasting, and plus equals means that I will increase every element in edgesdf data frame by 1. So let's run it. And we can see that now the first element is 1, everything is increased by 1. Let's describe edgesdf right now, and we can see indeed that now the indexing starts with 1 and ends at 37,700. So in the same way, we need to increase the classesdf, but only the ID column. So how can we increase the elements of ID column by 1? Well, we do exactly the same, but just extracting out the ID column from classesdf by using .id. So we get ID property. This operation does not copy data, so it's again in place operation, and we increase the ID column by 1. So now we get displayed only the ID column, and we can see it got increases by 1, but in the same way here, if we look at this classesdf data frame, everything got increased by 1. So now we have our data set that is using 1-based indexing both in classesdf and in edgesdf. So this summarizes the first step in our analysis, where we were doing the initial preparation of the data.